Air suspension update. The air suspension system is one of several areas in which design changes have been made to improve the performance and reliability of GMC motorhomes. All mechanical members of the 1975 motorhome's rear suspension have been modified for increased load capacity and improved durability characteristics. The 1975 motorhome's new air distribution system is made up of pre-assembled nylon harnesses. There's less chance of leaks developing because there are 18 fewer threaded fittings, and those that are used are a new plastic type with improved sealing ability. These new plastic fittings are interchangeable with the brass fittings on older models. Let's first go over some troubleshooting tips on the air distribution system, keeping in mind that any disassembly or assembly procedure required but not described in detail in this film can be found in your motorhome service manual or in dealer service technical bulletins. The air system must be completely free of leakage to function properly and avoid unnecessary compressor cycling. It's possible for leaks to develop anywhere, but the majority develop at air tube connections. In tracking down air leaks, it's best to start at the front of the vehicle with a soap and water solution and work back through all the lines and fittings. Of course, if you have a microsonic leak detector, you'll want to use that. It can detect leaks that might not show up with soap and water. All parts of the system, air lines, bellows, reservoir tank, and valves, can be checked with either soap and water or the detector. On vehicles with power leveling, check for leaks first with the vehicle completely lowered, then fully raised. Leaks at airline connections can often be stopped by tightening the fitting. If that doesn't do it, replace the fitting. These plastic fittings and the brass insert are available through your parts department. They are interchangeable with the brass fittings used on earlier motorhomes and should always be used for replacement on any motorhome. Also, the threads of a plastic pipe fitting going into metal should be wrapped with Teflon tape to ensure a tight seal. The new stem and nut assemblies make a better seal, thanks to a small O-ring in each that forms an airtight seat when torqued to specification. Correct torque for these fittings is 10 to 15 inch-pounds. Use no Teflon tape or sealing compound with these fittings. To replace a faulty fitting, either brass or plastic, first remove the old one by cutting it off square. Place a new brass insert into the end of the tube. Then slip the appropriate fitting over it. Special tool J25520 must be used to crimp the fitting in place. The tool is designed so that once the crimp is started, it must be completed before the tool will release, and it's impossible to crimp it too much. Once all fittings have been checked, the next items to look at for air leaks are the height control valves. They must be removed from the vehicle to be checked for internal leakage. Before removing, be sure to support the frame to prevent it from dropping down when air pressure is released from the air bellows. Be sure also to tape the ends of the disconnected air lines to keep dirt out. Even a minute particle of dirt can cause one of these valves to malfunction. Apply shop air to the inlet port. Then submerge the valve in water and watch for air bubbles. Be sure the valve arm is in neutral. No air should escape anywhere. Bubbles at the bellows port indicate the air inlet valve is faulty. Test again with shop air connected to the bellows port. Bubbles at the inlet port indicate that the inlet check valve is defective. If bubbles appear at the exhaust port, the exhaust valve is leaking. The valve can also leak around the cover plate. If it does, you should replace the cover plate gasket. After you check the valve, move the valve arm through its full travel to expel any water. Do this with shop air connected to both ports. If it is necessary to repair the valve, a repair kit is available for rebuilding. When you reinstall the valve, be certain the fittings are clean and undamaged. Do not use sealing compounds. It's unnecessary and only increases the chances of getting foreign material in the valve. Once installed, build up pressure again, check for leaks at the fittings, and check ride height dimension. The next items to check for leakage are the power level controls on vehicles so equipped. It's possible for these valves to leak internally as well as externally. External leakage can occur at the airline fittings as well as at the gasket between the two sections of the valve. Leakage at the fittings is usually the result of under or over torquing. Over torquing can crack plastic pipe fittings or, in the case of brass fittings, the valve body. If the valve leaks at the gasket, the entire valve assembly must be replaced. The valve will leak internally if internal parts are stuck or not seating properly. A symptom of internal leakage is constant exhausting of air at its exhaust port or the height control valve's exhaust port, with no lowering of the vehicle. Another is when the vehicle rises with the valve in any position except lower. The compressor runs constantly, and air will be exhausted at the leveling valve in the rear. If a valve shows symptoms of internal leakage, particularly a new one or one on a newly delivered vehicle, there is one possible cure short of replacing the valve. Disconnect the feed line, put in a Schrader valve, and apply shop air while turning the valve through all positions. This will possibly seat the internal spring and valve. If it doesn't, you'll have to replace the valve. On earlier motorhome models, the pressure regulator switch was in the airline between the compressor and the reservoir tank. With this setup, a leak-down condition could exist back through the compressor that would cause excessive compressor cycling. This situation could be mistaken for an air leak somewhere downstream of the reservoir. On newer motorhomes, the switch is plumbed into the system downstream of the reservoir tank, thereby reading a more constant pressure and eliminating the cycling condition. A field service kit has been released to convert older models to the new plumbing system. Be certain any motorhome you're working on with air leakage problems has the new plumbing arrangement. It's possible that leakage from an air bellows won't show up in a soap and water test. The leak could be concealed by the end piston when the vehicle is at rest. If you suspect this, use this test procedure. Release all pressure from the bellows. Disconnect the air inlet fitting and install a Schrader valve. Then, with the power level controls in hold, inflate the bellows with shop air to the proper ride height and take an accurate pressure reading. Drive the vehicle over a road that will cause plenty of flexing of the bellows. Then take another pressure reading. If air pressure's been lost, you know the bellows is leaking. It could be leaking at the O-ring at the inlet of the air bellows. To find out, remove the bellows, install a Schrader valve, apply shop air, and perform a soap test. If you observe leakage here, replace the O-ring. If the leakage is somewhere other than at the O-ring, you'll have to replace the bellows because it cannot be repaired. You should not overlook the air reservoir tank as a possible leakage point, particularly if it hasn't been drained regularly. Check all fittings and welds with the tank fully pressurized. You should urge owners to drain the tank every day if possible when the motorhome is in use. The vehicle should never be allowed to sit for long periods with moisture in this tank. You should drain it every time the unit is in for service. A less likely but still possible source of leakage is the nylon tubing itself. Here, in checking for leaks, a microsonic detector can be especially useful. When you check, be sure the system is fully pressurized. If any welding has ever been done on a vehicle close to air lines, check that area closely. Welding sparks can penetrate nylon, causing pinhole leaks. Check areas where the tubing may be rubbing against something that could cut it. All air lines should be secure and tied away from anything that could cut, abrade, or burn them. Here's another method of checking an airline. Disconnect both ends and plug one end with a pipe plug. Then pressurize the line with shop air. Take a pressure reading. Watch the gauge for any pressure leak down. If a leak is found, you don't necessarily have to replace the entire line. It's possible to repair it. Cut out the damaged section and connect the two remaining sections with a plastic coupling, part number 796-784. If a problem of slow pressure buildup in either bellows should exist, and the power leveling valves check out okay, it may be that an air line is clogged or otherwise restricted. Disconnect the line at both ends and blow through it to be sure the passage is clear. Look, too, for partial restrictions such as kinks or dents, which would call for replacement or repair of the line. Let's take a closer look now at the 1975 model's rear suspension. It's been redesigned with beefed-up components to give it a higher axle rating. It features new, larger wheel bearings and heavier spindles mounted on new control arms. The control arm pivot pins are larger, 1.5 inches in diameter. Motorhomes built prior to late '74 had 1.25-inch pins. There are 4 bushings in the new suspension for each pivot pin, rather than 2. The new bushings are bronze rather than Teflon. A keeper for each pin has also been added. A service kit is available to repair older motorhomes with the 1.25-inch pins. Some parts in the kit are the same as the old ones, but all of them should be installed when making the repair. The kit should be installed, however, only when the old-style bushings show wear. Wear is checked by measuring lateral play of the control arm at the spindle. To measure it, let the air out of the bellows by disconnecting the height control valve link and pushing down on the valve arm. Then, disconnect the bellows air inlet line. Set up a dial indicator at the spindle end of the control arm and measure lateral arm movement. If the total play is more than 0.125 inches, the bushings are worn and the new service bushings and pins should be installed. When removing a control arm, be sure to block the arm with a piece of wood before removing the air bellows. Also, be sure to tape off the brake lines when they're disconnected. The tools required to install the bushings, a bushing remover, installer, and reamer, are in Toolkit J25474. Also necessary, but not part of the kit, is the standard Kentmore drive handle J8092. With the control arm secured in a vise, thread the remover into the old bushing about 1 inch. Then, using a brass drift, tap on the remover from the opposite side to push the old bushing out of the control arm. Mount the installer on the drive handle, then place the new bushing on the head of the installer so that the lubrication groove will be towards the outside of the control arm. Install the bushing in the control arm using gentle taps on the drive handle. Be sure not to cock the bushing. Repeat the procedure on the opposite side of the control arm. Each arm takes 2 bushings, inner and outer. With both bushings installed, ream them to size with the reamer. Always turn the reamer clockwise, even when removing. After cleaning out the chips with an air hose, the control arm is ready for reinstallation. Next, let's look at ride height adjustment. It should always be within specifications to avoid poor handling and unnecessary wear of various vehicle components. Power controls must be in the travel position when you take the measurements. Also, the vehicle should be on a level surface with full vehicle weight on the wheels and with the tires properly inflated. Ride height is measured from the top of the elongated slots in the frame rail to the ground. Of course, the measurement should be the same on both sides of the vehicle. A 3/4, 1 inch, and 1 3/4 inch sockets and special tool J22517-01 are the only tools needed to adjust front ride height. Whenever front ride height is changed, however, front wheel alignment should be checked and adjusted if necessary. If the front end is not within height specifications, put the vehicle on a hoist or jack the front wheel off the ground. Do not attempt to turn the torsion bar adjusting bolt without using the special tool. Doing so could strip out the bolt. The special tool is used to move the torsion bar rear anchor arm, so the adjusting bolt is not loaded. The tool is placed across the top of the frame crossmember with the point in the top secured in the hole in the top of the crossmember. The bar with the adjusting bolts is fitted to the U-shaped part of the tool and the two nuts drawn up tight. The adjusting bolt is turned clockwise to increase ride height and counterclockwise to lower it. With the adjustment made, the bolt is rotated back to contact the anchor arm. Release the tool and recheck the height with the vehicle back on the ground. Go through the procedure again if further adjustments are needed. Rear ride height is adjusted by loosening the nut on the height control valve arm and changing the position of the arm relative to the valve. The valve arm will move approximately 1/2 inch fore and aft without causing any valve action due to the time delay feature. With a little experience, you will be able to judge how much adjustment is needed at the lever to make the required change in ride height. Good handling and maximum tire life are dependent on accurate alignment of the rear wheels. The empty vehicle must be level, with full vehicle weight on the wheels and tires properly inflated before checking alignment. Toe-in is checked by measuring the two distances, F and G. G should equal F plus or minus 60 thousandths. Measurements can be made at the center of the tire tread or at the inside of the tire or rim. Both measurements must be taken at the same height. Camber must be measured with an accurate gauge. It should be from 1 to 1.5 degrees positive. That's tilted out at the top. Excessive positive camber wears the outer shoulder of the tire. Negative or reverse camber puts extra wear on the inner shoulder. Toe-in and camber adjustments are made by placing shims between the suspension bracket and frame. Horizontal shims are used to change camber, vertical shims for toe adjustments. The alignment of all four wheels should be the same. If they are not, it could be due to 1. Loose wheel bearings, 2. Worn control arm bushings, 3. Loose suspension bracket bolts, 4. A bent control arm, wheel, or the frame itself. To adjust wheel bearings, tighten the nut to from 25 to 30 foot-pounds. Back off the nut 1/2 turn, then tighten it finger tight. Secure the nut there if possible. If not, back off the nut to the first securing position. End play should be between 1 and 5 thousandths. We covered the procedure for checking wear of control arm bushings earlier. Remember, total lateral movement should not exceed 0.125 inch. All suspension bracket bolts should be checked for proper torque whenever wheels get out of alignment. If any are found to be loose, check for wear and replace if necessary. If you suspect a control arm is bent, you'll need a straight edge to check it. The spindle mounting surface A and the pivot surface B should be parallel, with a distance of 70 thousandths between the two parallel planes. Procedures for checking wheel runout and frame straightness are set forth in the Motorhome Maintenance Manual.